Can you, first of all, realize that this situation is where you're working the opposite way. You're given a situation, even with a picture here, and you're asked to do two things here. I'd like us to set this up together for this example. You may have, again, done this by looking in the textbook, which is good, if you're ahead of the game here. And then I'm going to ask you to draw the graph for the second part, okay? Make sure you read carefully what you're asked to draw a graph of. First of all, it gives you a situation. Josephine leaves her home and walks to the store. After buying a drink, she slowly jogs to her friend's house. Josephine visits her friends for a while and then runs directly home. Okay? It doesn't give you any times involved, but what are some key words in there that you need to know? Should I pick on certain people who aren't listening? Or does anybody want to volunteer anything here? What are some key words in here? There's no numbers in there. I know very early on in grade 1 or 2 you learned just look for the numbers in the question and multiply them together and that's probably the answer. Right? There's no numbers in there. What are some key words though? What's one key word? Slowly is a key word. What are some other key words? Did you have one or were you going to say that one?
I was going to say run.
Run. Absolutely. Running here. Where's running? Runs directly home. That's a key word here because it's going to indicate something. What do you think? Walk is another key word. You could underline a few more, right? Because those words give you an idea of the rate of change. How do we represent rate of change on our graph? These are rate of change of distance. If this is a distance time graph, the rate is going to be the slope of the graph. Now I'm going to be specific here, and actually I've made a big assumption here that you understand why I put distance up here and why I put time here. You may have learned this in science. You may have learned it in grade 9 in math. A concept that you have to learn is something about, and it comes up formally in section 6.2, but the difference between what's called the independent variable and the dependent variable. Okay? We have two variables in this situation. We have time, because it tells us we want to draw a distance time graph. We have to decide which one is independent, which one is dependent. We want to think about here, we have distance and we have time. Does her distance from her house depend on how much time has passed? Or does how much time has passed depend on her distance? Let me show you here by Paul. Now, so this situation here, if we start the stopwatch when she leaves her house, okay? I'm not going to embarrass myself and try and draw here, but you can imagine her coming out of her house and go in that direction, right? So we start the timer, she leaves her house. We have the distance from her house at any time. Does the distance she is away from her house depend on what that stopwatch says? Or does what this stopwatch say depend on how far she is from her house? What do you think? Does the distance away from her house depend on what that stopwatch says? Does the distance depend on how much time has passed? Or does how much time passes, does what that stopwatch says depend on how far away she is from her house? One of them is independent of the other. One of them is dependent on the other one. The time depends on the distance? What if she's stopped right now? Like, what's happening with that thing? Like, can the time pass without her making any distance? Yes. Can it be the other way? Can she change the distance without any time passing? Okay. If it's science fiction, you can freeze time and go back in time and all that. But in the real world, the time keeps going by, right? That time is ticking away, and that's the independent one. Okay, the time is independent. Time is independent. Distance is the dependent. The way you set it up is you always put the dependent one on the vertical axis, and you put the independent one on the horizontal axis. All right? When you're setting this up. We should be specific here too. Don't just say distance. Say distance from her house because that's what this says here. Distance from her house. Because we could do the distance from a lot of different places. You could do the distance from her house, or you could do the distance from what? The store. You could do the distance from the friend's house. You could do a lot of different things. And in fact, the second part of this asks you to do the distance from, that asks you to do the distance from the store, which is different. If you're going to draw this then, at the start, so we're going to say distance from home. Distance from home. You can put some numbers on one of those axes. Which numbers can we put? Which one can we put numbers? Distance or time? What do we have? What do we have numbers for? Distance. We got 0. What should I make my? If I made a scale here, how high should I make it go up? What's the farthest away she can get? 4. So I'm going to make this 4 because I want to be able to fit it on here. Okay. I don't want to have to make the scale work in the situation. Let's even move that over. How far is she away at the start? Here she is at the start. She's a giant blue dot. How far away is she at the start? She is how far? I know. Okay, I'll embarrass myself and draw a stick person. Except it's. I guess we should put some hair on this. She's got orange hair. Okay. Oh no, that's not good. Okay, here she is at the start. And what's the graph got to look like? Here she is moving along. What does it say happens to her first? What happens first? What does she do? Walks to the store, goes pretty slowly, right? What does that first part of the graph look like then? She starts how far away? 0 from her house. Does it look like this? No, because what would that be? That would be really slow at the start, slow motion, and then she's getting faster, right? We don't want that. We don't want this either. What would that say? She goes hard out of the gate and then she kind of trails off at the end. She walks to the store, you walk at a pretty constant rate. Is it like this or more like this, do you think? We don't have any numbers here. You could make up some numbers if you want. How long do you think it would take to walk 1 kilometer? Let's just say maybe 10 minutes, and we can make up some numbers. You don't have to make up numbers. You notice the previous graphs in here didn't have any numbers involved. But let's say she walks 1 kilometer in 10 minutes. So she gets to the store. What happens at the store? She goes in, buys a drink and stuff. So what do I have to do here for a while? Flat line, how long does that take her? 5 minutes? You want to do 5 minutes? Okay. So here's 20. She takes 5 minutes and then, obviously this is open to debate, but she takes 5 minutes and then what happens? She slowly jogs, but is that slowly jogs, how would it compare to this? It's faster, so we got to make sure it's steeper. She did 1 kilometer in 10 minutes. 1 kilometer in 10 minutes. 1 kilometer in 10 minutes is 1/10 of a kilometer per minute. You need her to go faster than that. You need her to do, how about if she does 3 kilometers in 10 minutes? Is that a good jogging speed, 3 kilometers in 10 minutes? That's probably more than jogging, but maybe we should do 15 minutes? Is that still faster than before? I don't know. I'm not up on my how long it takes, but you got to make sure it's steeper. So maybe it takes till 30 here. That's a bit steeper. It doesn't really look steeper, but my scale's not great. You could argue anywhere in there. You could, as long as you made it steeper somehow. And then what does she do at her friend's house? She says, oh, I didn't move her over there, eh? I'm not going to draw her friend. She goes over to her friend's house. Hello, friend. How are you today? Then what does she do? She stays there for a while. She doesn't say, okay, gotta go. She stays there for a while. What happens? How long does she stay?
20 minutes.
20 minutes, okay. So somewhere over here, she then does what? Yeah, I'm going to do this again because we said we were going to stick with that. She stays for a while. How long does she stay? I came to visit you for 10 minutes. Then what? How long does it take her to get home? How steep could we make this? Could we make it this steep? I don't think you can run 4 kilometers in 2 minutes, right? What do you think? What do you think's a good running speed? What would you guess? 4 kilometers in how many minutes?
No.
3. I think about our thing here. 1 kilometer in 10 minutes. Is this our speeds are ridiculous here, by the way. 1 kilometer in 10 minutes. Walking, I don't know. They're not ridiculous, I guess, but they're not ridiculous. No, but 4 kilometers in how fast? How many minutes? How many minutes would it take her to run? Well, the only thing I can relate to here is I know that if you run really fast, like people have beat this a lot, but maybe I don't know when it was 50 years ago or something. They beat the 1 minute or 4 minute mile. 1 mile in 4 minutes. 1 mile is about 1.6 kilometers. Oops. In 4 minutes. 4 minutes. So I always try to relate to that too. You can't really run much faster than that. 1.6 kilometers in 4 minutes. It doesn't really help us here. This is about 2 or 3 times more than that. So if we were running really fast, let's say we could do 4 kilometers in 10 or 12 minutes. I don't know. 10 minutes, let's say. So let's say she was really fast and she did 4 kilometers in 10 minutes. Just for the sake of argument here. As long as that is the steepest line on the graph. Okay? That took a lot longer than I thought, and we better get her back home here. There she is. Okay? She has a sleepover. The line is really long here. This one asks you to make something but the distance from the store. Now you could get crazy and call distances positive and negative to do with whatever side she is from the store, but let's not do that. Let's just say the distance, whichever direction it is, let's not care about the direction. I'm not going to do that one with you. I want you to draw that right now. I'll put a graph here in about 2 or 3 minutes after you're done, and you can check, okay? Hopefully you managed to draw something. If you're doing this as distance being positive regardless of which side of the house you're on, side of the store you're on, because this is distance from the store, right? Distance from store. Distance from the store at 0 here. And at the most, how far from the store could you be? What's the farthest away she can be from the store? I think 3, so we only really need it to go up to 3. I'll put 3 there. And then time, you can put time on there, but basically, at the beginning she starts at 1, and she gets closer to the store pretty slowly. She stays at the store for a little bit. Then she gets farther from the store, but she goes faster than before. She stays at her friend's house for a while, probably longer than 10 minutes, but we'll do that. And then she gets home, all the way home pretty quickly. Okay? And there's one last piece I need here. What else do I need? You got to go back to 1. She's got to go up like this. Okay? Do you understand why it has to go up like that? Some of you might have done it this way, calling the distance on one side negative, distance on the other side positive. You can do that if you want. You can say that her house is negative distance and her friend's house is positive distance. So you could start at -1, saying she's 1 kilometer before the store, and then she gets to the store, she stays at the store, she gets even further, she stays there, and then she runs all the way home, and this would be straight down like that. If you wanted to do that, you could. Okay? If you made negative distances, that's fine. So either one of those graphs. All right? Can you get going on this assignment here, please? We've talked about two things here, relationships between two quantities, graphs of relations. We've actually talked about rates of change as well, and how the slope of the line represents the rate of change. You need to do this, okay? And you need to do this. You have some time right now to use to do that. You can get a pretty good chunk of this done.